Machine learning is transforming our world. From self-driving cars to personalized recommendations, its impact is undeniable. Java, a language known for its robustness and scalability, plays a crucial role in bringing these intelligent applications to life. This essay explores the synergy between Java and machine learning, highlighting how Java's strengths empower developers to build powerful, efficient, and scalable machine learning solutions. Java's long-standing presence in the enterprise world brings significant advantages to the field of machine learning. Its mature ecosystem, rich libraries, and strong community support make it an ideal choice for developing complex and demanding machine learning applications. Whether you're a seasoned Java developer or new to the language, understanding Java's capabilities in machine learning opens a world of possibilities. This essay serves as a practical guide to navigating the world of Java for machine learning. We'll delve into the core features that make Java a compelling choice, explore popular libraries, and provide hands-on examples to get you started. Get ready to embark on an exciting journey of building intelligent applications with Java. Let's dive in and uncover the power of Java for machine learning. From understanding its core strengths to building your first model, this guide will equip you with the knowledge and tools to harness the combined potential of Java and machine learning. Java's reputation for robustness and performance precedes it, making it a natural fit for the demanding world of machine learning. These inherent strengths translate into tangible benefits for developers building intelligent applications. Java's strict type system and compile-time error checking contribute to its robustness. This rigor ensures that code is thoroughly vetted before runtime, reducing the likelihood of unexpected errors during model training or deployment. This reliability is crucial in machine learning, where even small errors can have significant consequences on model accuracy and performance. Performance is paramount in machine learning, where algorithms often process massive datasets. Java's efficiency, stemming from its just-in-time JIT compilation and optimized bytecode, ensures that models train and run swiftly. This speed translates into faster iterations during development and quicker responses in real-time applications. Java's robustness and performance are not just abstract concepts, they are fundamental pillars upon which successful machine learning applications are built. These characteristics empower developers to create reliable, efficient, and high-performing intelligent systems. Machine learning thrives on data. The ability to process massive datasets efficiently is paramount for building accurate and robust models. Java's robust support for multithreading and concurrency makes it an excellent choice for handling the demands of large-scale machine learning. Multithreading allows Java programs to execute multiple threads concurrently, making optimal use of modern multi-core processors. This capability is essential for machine learning algorithms that can be parallelized, significantly reducing training times and improving overall performance. Java provides a rich set of tools and APIs for managing threads and concurrent operations. These tools simplify the process of dividing complex machine learning tasks into smaller, parallelizable units, allowing developers to exploit the full potential of their hardware. Java's inherent support for multithreading and concurrency equips developers with the tools to unlock the power of parallel processing for machine learning. This capability is essential for tackling the ever-growing datasets that fuel today's most sophisticated machine learning models. Java's vibrant ecosystem boasts a wealth of libraries, specifically designed for machine learning, providing developers with a comprehensive toolkit for building intelligent applications. These libraries offer pre-built algorithms, data processing capabilities, and model evaluation tools, accelerating the development process. Apache Spark, a powerful distributed computing framework, seamlessly integrates with Java, enabling the processing of massive datasets across clusters of machines. Its support for machine learning through MLlib provides a scalable platform for building and deploying large-scale machine learning models. Deep Learning 4J, a deep learning library for Java, offers a comprehensive suite of tools for building and training deep neural networks. Its intuitive API and support for GPUs make it accessible for both beginners and experienced practitioners in the field of deep learning. Weka, a collection of machine learning algorithms implemented in Java, provides a user-friendly interface and a wide range of algorithms for data pre-processing, classification, regression, and clustering. Its versatility and ease of use make it a popular choice for both research and practical applications. These libraries represent just a glimpse into the rich ecosystem of Java tools available for machine learning. Leveraging these resources empowers developers to focus on building and deploying intelligent applications without reinventing the wheel.